Part 2, continuing on with the same problem we were working on, where we had to find the inverse of this given function. And now we're at the step where we want to graph this function and its inverse. So let's go ahead and use all the knowledge and skills that we've learned so far to graph this rational function. We'll start by the vertical asymptote. So you take the bottom, set it equal to 0, and solve for x. So x would equal 2. So you'll have a vertical asymptote at x equals 2. For the horizontal asymptote, the degree of the top and the degree of the bottom is the same. When the degree of the top and the bottom are the same, you're simply going to divide their coefficients. So you would have a horizontal asymptote at y equals 1. Now, you're going to have the parent function of 1 over x because you have 1x at the bottom. So recall that it's normally in, the branches are in quadrant 1 and 3. So when you make those transformations of those asymptotes, this is what the original graph is going to look like. Now, once you get the original graph, remember all you have to do from there is take a few points from this graph and swap the x and y values and then regraph it. And then what you'll have then is the inverse of that graph. And now let's move on to finding the domain and range of both the function and its inverse. So you should know that the domain and range of the inverse and its original function are interchanged, just like the x and y values are swapped when we graph. So let's start by finding the domain. So remember, to find a domain, all you have to do is take the bottom, set it equal to 0, and solve for x. So x equals 2 in this case, which means 2 is the only number you're not allowed to plug into this function. Why? Because if you plug in a 2, it would make it undefined. So the domain would be all real numbers, but not 2. And if that's the domain of your original function, it becomes the range of your inverse. Now let's find the domain of the inverse function. Again, all you have to do is take the bottom, set it equal to 0, and solve for x. So to solve this for x, it would be 1. So 1 is the only number you're not allowed to plug in. Why? Because 1 would make the bottom undefined. So the domain of the inverse is all numbers but not 1. So if that's the domain of the inverse, it becomes the range of the original function.